In this section, we are arguing about physical properties of materials. Physical properties are static natures, while mechanical properties are dynamic nature against external forces. Examples of the physical properties include density, electrical conductivity, magnetism, linear coefficient of thermal expansion, and thermal conductivity. Each of these properties are introduced in the following. Density is the mass per unit volume. It is used to evaluate whether a material is heavy or light. The higher the value, the heavier the material. The table shows the densities of typical materials. Iron and aluminum are particularly important in machine design. Note that aluminum weighs about 1/3 of iron. Electrical conductivity indicates how easily electricity flows in a material. The higher the value, the easier the electricity flows. Electrical resistance indicates how difficult for electricity to flow in a material. This is the opposite property of the electrical conductivity. In other words, the lower the value, the easier the flow of electricity. Some examples of electrical conductivity and resistance are shown in the table below. It can be seen that aluminum, gold, silver, and copper conduct electricity more easily than iron. Copper and aluminum are widely used for the purpose of conducting electricity. Magnetism indicates how a material reacts in magnetic field. Iron, cobalt, and nickel are known to be magnetic materials. On the other hand, gold, silver, copper, and aluminum are known to be non-magnetic materials. Materials with magnetism can be classified into 4 categories. They are hard magnetic materials, soft magnetic materials, magnet-strictive material, and magnet-resistive material. Hard magnetic materials are used as permanent magnets. Ferrite and neodymium magnets are examples. Soft magnetic material can switch the magnetic field on and off. For example, they are used for magnetic cores in motors. Magnet-strictive material deforms exposed to magnetic field. It is used in ultrasonic oscillators and other devices. Magnet-resistive material is a material its electrical resistance changes when a magnetic field is applied. Machine designers need to consider the environment in which the machine products are used, including the effect of heat. There are 2 properties related to how a material is influenced by heat. They are linear coefficient of thermal expansion and thermal conductivity. A material expands as the temperature rises. In machine design, you often need to consider the linear coefficient of thermal expansion. The value of iron, aluminum, and glass are shown in the list. This property defines the expansion of a material along one direction. There is also a parameter called thermal expansion coefficient that defines the behavior of volume. You should distinguish these 2 properties. Let me explain little more detail about the linear coefficient of thermal expansion. The linear coefficient of thermal expansion alpha defines the behavior of a long or thin material against heat. Imagine there is a bar with a length of L. When the bar is heated to rise its temperature by delta T, the bar elongates by delta L. The elongation is said to be proportional to the increase of temperature, delta T. The proportional constant is the linear coefficient of thermal expansion as the following equation: delta L equal alpha L delta T. For example, the elongation of a 400 mm long aluminum bar when the temperature rises by 10 degrees is calculated by this equation. Thermal conductivity determines the speed of heat transfer, how a material transfers the heat. It is taken into account when a material needs to be cooled or kept warm. For example, components that require cooling, such as heat sink, should have a higher thermal conductivity. Some examples of thermal conductivity are listed here. Aluminum has a higher thermal conductivity than iron and is less expensive than silver or copper. So it is used for heat dissipation plates. On the other hand, materials that need to keep the heat should have lower thermal conductivity, such as glass. These materials are used for insulation.